You can write the most detailed user story in the world in a plain text file, but to the corporate algorithm, it remains entirely invisible. The algocratic environment operates strictly on what it can measure. If an effort is not formally scheduled, the system assumes you are doing nothing. Within this architecture, work transitions from an abstract thought to a physical reality only when it is pinned to a Kanban board. But simply moving a user story to a column labeled To Do is insufficient. It must also be assigned a measurable cost. That cost dictates your allocation. It determines whether a creator accrues their exposure units or sees their resources diverted elsewhere. Without a numeric cost attached to the work, the algorithm has no way to allocate bandwidth, predict timelines, or track your velocity. Uncosted work is a hobby. Costed work is a business. And you are here to run a business. When forced to assign a cost, the instinct of almost every junior developer is to estimate tasks in raw hours. This fails predictably because the human brain is psychologically ill-equipped to estimate time accurately, especially for complex engineering problems. The industry-standard alternative to guessing time is relative sizing. Relative sizing works because while humans struggle to project abstract time, we are highly capable of comparing the volume of one unknown task directly against a task we already understand. Instead of counting clock ticks, we measure three factors: complexity, effort, and risk. A highly complex architectural decision might take exactly 1 hour to write, while a simple but tedious UI update might take a full day waiting on a slow build pipeline. Time fluctuates based on your environment and tooling, but the inherent complexity of the task itself remains constant. To survive Sprint 1, you must adopt a specific mathematical tool calibrated to measure that complexity. At Algocratic Media, that tool is the modified Fibonacci sequence. Shifting away from the hour allows for a calculation of velocity based on the task's inherent nature, providing a more reliable forecast for the end of the sprint. The modified Fibonacci scale mandates a strict set of values for your sprint planning: 1, 2, 3, 5, 8, and 13. A 1-point ticket is a trivial change, like a typo. The 3-point ticket is your baseline anchor, a standard feature with 0 unknowns. Estimate everything by asking, is it larger or smaller? An 8 is complex, multi-step work. A 13 is a structural warning. A 13-point ticket is too large to safely schedule into a sprint. It must be immediately broken down into smaller, manageable user stories. When dealing with unknown complexity, overestimating your constraints is always safer than underestimating them. By assigning these specific Fibonacci weights, you force an abstract wish list of features into a mathematically sound blueprint. Now that every user story possesses a Fibonacci score, we have to look at the reality of your backlog. If you sum up the points of a typical proposed build, you will quickly reveal a massive, unmanageable total. Shodan, your channel success partner, imposes a hard constraint on your capacity. The algorithm allocates exactly 13 story points for Sprint 1, no more. The mathematical reality is that your current backlog totals far more than that 13-point limit. Trying to squeeze a 25-point backlog into a 13-point capacity leads to missing deadlines and a broken build. To survive the sprint, you need a ruthless triage system to decide what survives the cut and what is discarded. A backlog without strict capacity constraints is merely a wish list. It is not an executable plan. We enforce that triage using the MoSCoW method, a framework for backlog grooming and scope survival. This diagram maps out the first category, must-have features. These are non-negotiable. If absent, the application lacks the core capability required to function. The math is rigid. The total points of must-have tickets cannot mathematically exceed your 13-point sprint capacity. Next are the should-have features. These are important, but the product can launch without them because a manual workaround exists. Then we have could-have features. These are cheap additions that you will only execute if your team's velocity is higher than expected. Finally, we define the won't-have label. These are items that are explicitly out of scope for the current sprint. Junior developers often fear under-delivering, causing them to incorrectly label every single feature as a must-have. Moving an item to won't-have is a defensive perimeter. It manages client expectations before you write a single line of code. Scoping out work with the MoSCoW method is just as vital an engineering skill as writing the software itself. By applying these labels, a messy, impossible backlog transforms into a clean, survivable 13-point sprint plan. The won't have and could have tickets are safely deferred to a future Sprint 2 folder, clearing your immediate path. Shipping 3 fully tested, working features provides more value to the platform than pushing 5 that are broken or untested. Remember, if every feature on your board is marked as a priority, nothing is actually a priority. Once Shodan accepts your groomed board, you prove you understand the logic of the corporate trapezoid. It rewards consistent delivery, not impossible ambition. Kill a feature before it kills your timeline. Size your work accurately and protect your board.